Hi students, today I am going to explain light energy chapter 4 of physics for 7th class students. So light travels in a straight line. So light from an object can move through space and reach to the human eye that will enable us to see this page or face in our mirror. So this process is known as reflection. It obeys a law known as reflection of light. So whenever is the light, it will move into the space and it will reflect back and comes to our human eye so that we can see the things. So this process is called reflection, and the law which it is obeying is called law of reflection. We know that light travels in air at a speed called 3 into 10 to the power of 8 meters per second, or 3 lakh kilometers per second. So in other mediums like glass or water, its speed is less, it slows down. So light from the sun is composed of 7 colors. We know the colors of the objects fascinates everyone. So physicists have found that all the colors can be explained as the addition of 3 primary colors. What are the 3 primary colors? Red, green and blue. Yes, no. So colors that are seen on a TV computer screen arise due to the combination of these primary colors. This red, green and blue. These 3 colors are called primary colors or first colors, and the screen which we see, or a computer screen or a TV screen, we can see because of these colors only. So appearance of colors of an object is why? Because of the absorption. So the light will be absorbed and reflected back at different colors, so of the object. So this is the theme of the lesson. So let's go to the concept. So what is light? We have know that light is also a form of energy which will help us for the sensation of sight, to see the objects. So we cannot see light, but objects around us can only be seen in the presence of light. Directly we cannot see the light. So but the objects we can see in the light because of presence of light. So objects around us are not seen in dark. When the light is not there, we cannot see in the dark the objects. So the objects are seen when light after striking them return in the same medium and reaches our eyes. So when we will see the objects, when the light after striking that objects, it returns in the same path, same medium, and the same medium, and it reaches our eyes. So it travels in a straight line. So it is called rectilinear propagation of light. So when light travels in a straight line, it is called rectilinear propagation of light. So because of this rectilinear propagation only, it will give shadows when an opaque object is placed in it. So the medium through which light passes easily is called transparent medium. When the light is completely passed into it, it is called transparent medium. It will not produce any shadows because all the light will be completely passed into it. So light can travel in vacuum. Therefore, we receive light from the sun through the space. So from the space also, sun is giving the light. We can receive light because light can travel even in the vacuum also. So every day when you comb your hair, you stand in front of the mirror and you will see yourself. Yes, no. You can also see your image in the still water also. When the water is not moving, in the still water of a tank, we can see our image. So on a surface of a polished table, or a silver polished utensils, or shining steel plate, a new plate. So image how it is formed when a light is reflected by you, the strikes that surface. For example, we are seeing in a mirror or a plate, the light will fall on that surface and it strikes back to reach our eyes. Then this returning of the light in the same medium is called reflection of light. Because of this reflection we can see. Then we'll see what is reflection now. So that is so the returning of light in the same medium after striking a surface, it is called reflection of light. So for example, if you throw a ball on the ground, you notice that it rebounds after striking the ground. Yes, no, when we throw a ball, it strikes and again it comes back. So similarly, light falls on the shiny surface such as mirror. It again comes back in the same medium after striking. So when light falls on an object, a part of the light is reflected. So whatever is the light falls on the object, some part it will be reflected back. Different objects reflect this light on different extent. Some will reflect all the light it is passed, some little light. So a highly polished and smooth surface such as plane mirror will reflect maximum light falling on it, while a transparent object reflect the least amount of light because it will absorb all the light. It will reflect only little amount. And black objects, it will absorb all the light and it will not reflect only. So when we see the plane mirror next, a plane mirror, what it is made up of? Silvering one side of a thin plain glass plate. We take a thin plain glass plate. So the surface on which silvering is done, one side the silvering is done, it is called silvered surface, while the other is polished surface or reflecting surface on which the light falls and reflects back. So this one side is made opaque and one side is for reflecting the light. Then this is a plane mirror, and let's see. So the other surface of glass plate is called reflecting surface, where the light is reflected and the silver surface is coated with some opaque material. So that side the silver surface is coated with some opaque material to safeguard the silvering on it. So the light incident on a plane mirror enters from the front side of the polished surface and reflects from the silvered surface. The coating being opaque on the other side, it will not allow the light to pass through it. So that side we cannot see the image, only the reflected side we can see the image. Then this we can see with the activity. Fix a comb on one side of a large thermocol sheet. So on a large thermocol sheet, fix one comb and fix a mirror at an angle on the other side as shown in the figure. Pass a beam of light from a torch through the comb. You will get a pattern similar like this. So the silver surface of the mirror being opaque, this side does not allow any light to pass through it. So no reflection of the comb can be seen behind the mirror, but we can see front of the mirror. Then from this you can conclude that light rays falling on the comb travel in straight lines. So here they are traveling in a straight lines and they get reflected from the plane mirror to form a pattern as shown in the figure. Then so I am telling what is incident ray, some words we are using here. So I will explain what are they. So in the process of reflection, what is incident ray? So the ray of light that is striking the surface. So whatever is the ray of light, it is striking the surface. It is called incidenting on the surface. It is called incident ray. Next is point of incidence. The point at which incidence strikes the surface, it is called point of incidence. At what point it is striking. So the rays which is incidenting, at what point on the surface it is touching, then it is called point of incidence. And a reflected ray, the ray which is returning back after incidenting, it is called reflected ray. And normal, the perpendicular drawn on the surface at the point of incidence is called normal. So here we can see this is a point of incidence 0. This is the incident ray and this is the reflected ray. So here the angle between the incident and ray, a normal, is called angle of incidence, and the perpendicular drawn on the surface at the point of incidence. So at the point of incidence we are drawing a line perpendicularly, it is called normal, and the angle it is making between the incident ray and the normal and the angle of incident is called I. So it is called angle of incidence, and this is angle of reflection. So how much angle it is incidenting. So we draw normal to know the angle. So this is I, angle of incident, at what angle it is incidenting and what angle it is reflecting, that is angle of reflection, that is between the reflected ray and the normal, represented by R. So like this we can see. So I is equal to angle AON and R is equal to angle BON. So like this we can tell. Then what is the loss of reflection of light? So let's see, the reflection of light at a surface obeys the two laws. What are they? So angle of incidence will be always equal to angle of reflection. Means I will be always equal to R. Angle I is equal to angle R. Angle AON is equal to angle BON. So that is what they told. Angle A1 is equal to angle BON or angle I is equal to angle R. So at whatever is the angle it is incidenting, that much angle only it will reflect. Then the incident ray, the reflected ray, normal, all will lie in the same plane. So we can see here, incident ray, reflected ray, normal, point of incidence, all will lie in the same plane. So all will lie in the same plane. So let us take PQRS. S0 is a plane mirror on which EFGH is a plane normal to the plane mirror at the point of incidence O. So which contains the incident ray OA and the reflected ray OB and the normal ON. So here we can see all are in the same plane and I is equal to R. Right. Then, so we can verify the laws of reflection. For example, take a drawing board. So we have to take a drawing board and a white sheet of paper. Fix the white sheet of paper on this drawing board and draw a straight line M1 on a as shown in the figure. So M1 on the line, one line. On the line M1, take a point O nearly at its middle. So at the middle, take point O and draw a line OA. So draw a line OA such that angle MOA is less than 90. So it should be less than 90 and draw a normal ON. So perpendicular straight on MM1 at point O. And now take small plane mirror and place its long edge along the line MM1. Use the plasticine to fix the mirror on the paper so that it stands upright. We have to make it stand upright. We have to attach it. Now fix two pins P and Q. So we have to fix pins P and Q vertically on the line OA. So on the line OA, two pins we attach it. So what happens? Then set our eye on the other hand of the normal ON. So on the other hand of the normal ON along as the direction as shown in the figure. So you will see the images P dash, Q dash. So these are the pins. When we see from here, we can see the image P dash and Q dash. See, set your eye in line with two images P dash and Q dash and fix two more pins R and S. So first we fixed P and Q. We got P dash, Q dash and again fix two more pins R and S on the paper in the front of mirror such that both of them are in the line P and Q. P dash and Q dash. That image also same. P dash and Q dash means angle of incidence and angle of reflected is same. So now remove the immer, draw small circles like this PQRS so as to make their position as shown in the figure. So we can verify. So the angle of incidence and angle of reflection is same and all no angle of incidence and angle of reflection are same and they are lying in the same plane. Then draw a line OB. So draw a line OB. So from O to B and also joining the points R and S. AO is the incident ray, OB is the reflected ray and ON is the normal at the point of incidence. Now by using a protractor we should measure the angles. So by using a protractor we should measure the angles of I and R. Now after measuring, so we can observe that both are same, so equal. So this verifies that the two laws are applicable. We can verify the second law also because they are all in the same plane. So like this we can do. Then reflection of a ray of light normally incident on a plane mirror. So in figure 4.7 like this. So light AO. Light is passing normally incident on a plane mirror M1 at the point of incidence O straight. Now we are giving a light not at an angle normally means 90 degrees. Since the angle of incidence is measured with the normal to the mirror and not with the surface of the mirror, the angle of incidence of the ray will be 0 and not 90. We should not take it at 90 at because angle we should take 0 because we are measuring the angle of incidence or angle of reflection according to the normal. So both are merged. Yes, no. So we measured. Yes, no. From here we are measuring these two. So when the angle of incidence only here there. So from here to here it merged. So it will become 0. So when the angle of incidence is 0, then angle of reflection will also be 0. It simply shows that a ray of light incident normally after reflection from the plane mirror retraces its path as shown. So however it comes, the same path it will go out. So because the angle is 0. Okay. Next, formation of image by a plane mirror. How the plane mirror will form the image. So image of a point object. So this is the point object. So figure 4.8 shows how a plane mirror forms the image of a point object. A point object O is placed. A point object O is placed in the front of the mirror M1. So a point object means a small object. So it is placed in front of the mirror M1. From the object O, rays of light travel in all directions. So from this object, rays of light will travel in all the direction. Hence the two rays OA and OB are shown, which are reflected as AC and BD. So these reflected rays enter our eyes and they appear to come from point I. So when we see the image, so it enters at the point I. We can see here from point I behind the mirror. We can see the objects are reflecting like this. So these reflected rays enter the eyes and they appear to come from point I behind the mirror. So the I is the virtual image of the point object O. Virtual image is the image which we are imagining. Yes, no? In this diagram, angle of incidence of ray OA is I1 and the angle of reflection is AC, that is nothing but R1. So I1 is equal to R1, and similarly angle of incidence OB is I2 and angle of reflection is BD, that is R2. Both are same. I2 is equal to R2. So locate the position of the image. Reflected rays AC and BD are produced backwards. So they are meeting at a point I. So the image is formed of the object I at the I. So the image is formed backwards at I. So measure your distances. So we have to measure the distances OM and IM using a ruler, so that OM will be equal to IM. So thus the perpendicular distance of the object from the mirror is equal to the perpendicular distance of the image from the mirror. So the distance of the object from the mirror is equal to the from the distance of the image from the mirror. So distance of the object from the mirror equal to the distance of the image to the mirror. In other words, image is that much far behind the mirror as the object is in front of it. How much distance the object we kept, that much distance in the backwards the image is formed. At least two incident rays of light from the point objects are measured to find the position of the image from the mirror. So the ray of incident normally on the mirror can also be taken as the one of the incident ray. Even the normal rays also we can take. And one more. So how the image of the object is formed? If there is a finite size, so it is very small. So point object, now some finite size. So as shown in the figure, plane mirror forms the image of an object of finite size, such as pencil. We took one pencil, so we know its length is no finite size AB. For this we have taken two incident rays from each of the extreme points A and B of the object. For each incident ray, the reflected ray will be there, and because of loss of reflection, angle I is equal to angle R. So the reflected rays are produced backwards. So the images of the extreme points A and B of the objects are obtained as A dash and B dash. Thus the image of the object is A dash B dash. So if you measure the sizes of AB and AB, your A dash size of the AB and A dash B dash using a ruler, we will find both are same. So size of the image is same as that of the object. So when we keep one finite size object, then so from this we can conclude, for an object in front of the plane mirror, the image is formed behind the mirror. So when we place an object in front of the mirror, the image will be formed behind the mirror and it cannot be obtained on a screen. So that's why it is a virtual image. The image is formed when the reflected rays are produced backwards, and the image is erect image, and the image will be same size, and the image is far behind the mirror as the object is in front of the mirror. So the whatever is the object we are keeping in front of the mirror, the image will be formed that much distance only in the back side. So these are the conclusions. Thank you.